Which point on the line y equals 2x plus 5 is closest to the origin? Okay. So this feels a little bit more cerebral than I like, but we can deal with it. We can work our way through. It won't be that bad. So looking at this line, the y-intercept point is 5, which I'm going to say is right there. And then there'll be a rise over run of 2 to 1. 2 rises for every 1 run. Actually, I could use a real line. A real line. No, maybe not. Darn you, real line. Hup. There we go. Like so. I'm good at that. Yeah, I'm happy. Okay. And so now what we want to do is find the minimum distance between the two. So I'm pretty sure there's a rule somewhere that says that the slope will be, it'll be a normal line here. There'll be a 90-degree angle between the origin and that. I'd rather not use that because I'm not actually sure that's true. Is it true? It's probably true. But we could probably work our way around it. So we don't know where we're going with this. So I'm just going to start writing up information. So when you see closest, I'm like, okay, we have a formula for distance. So I'm going to say distance with respect to, now I'll say distance. Stay ambiguous on what the details are. It'll be in terms of x and y, but I'll say x squared plus y squared square rooted. So I'll say that distance squared equals x squared plus y squared. The idea here is that if we minimize the distance squared, we'll also minimize the distance. So instead of being like, all right, you're 3 meters or 4 meters away, or I guess 2 meters, 3 meters, 4 meters, you'd be like, you're 4 meters squared, 9 meters squared, 16 meters squared. And the idea is, if you minimize one, you'll minimize the other. You might be like, wow, that's excessive. Why are you bothering with that? I'm trying to get rid of the square root. I just don't like square roots. Okay, so we have that. But then we also know, change colors because I'm changing thought processes. Y equals 2x plus 5. 2x plus 5. And so distance squared equals x squared plus 2x plus 5 squared, which we're going to have to FOIL, which will give us, FOIL is first, outside, inside, last, and just a way of doing multiplying binomials. So we have 2x plus 5, 2x plus 5, first, outside, inside, last. I don't know. I just always multiply everything by everything else. So we have 4x squared plus, let's see here, it'll be 2, it'll be 10x, but there'll be 2 of them, so it'll be 20x, and then we'll have plus 25. And simplifying this, we have 5x squared plus 20x plus 25. That's a 20x, not a 26. Now I'll take the derivative. So we'll do distance squared prime, which is 10x plus 20 plus 0 because it just goes away. The constant goes away. We'll set that equal to 0. So 10x plus 20 equals 0. X equals negative 20 over 10. X equals negative 2. So that'll be our critical point here. It might even be true. Okay, maybe. We'll go with that. And yes. And so then we go back to, let's see, our equation for y. Y equals 2x plus 5, which equals negative 2. 2 times negative 2 plus 5, which equals 5 minus 4. I just flipped the 2 around. And that equals 1. So our point will be negative 2, 1, which even looks like a possibility. Whoop. There we go. I know I don't actually have to move it closer to convince you that that's the same answer. Of all your questions here, the fact that I wrote -2, 1 here and it matches up, that's not your biggest question. Okay, so to backtrack, kind of show what we did here. So which point on this line is closest to the origin? We're like, okay, the origin is 0, 0. So in this distance thing here too, even though I wrote x, I really probably should have written x minus 0, y minus 0 squared, because the origin is 0, 0. So if it was a different point, not 0, 0, we'd have to plug in the values for that distance. But since the origin's at 0, I just kind of dropped that off. So then after we had an equation for distance, I then used distance squared instead of distance because it's easier for me to just drop the square root. And if you minimize distance squared, you're also going to minimize distance. You don't have to take my word for that. You can totally work this out with the square root in there, and you should get the same answer. If you don't, then I made a terrible mistake, not just in this, but probably with many other things in life. So then after we have our equation, I called it distance squared, and it's, in terms of x. We then took the derivative of such, set equal to 0, and got our critical point for x. Now I assumed that was a minimum just because it seems kind of obvious that like way up here would be larger. So it seems like the minimum would be about right there. And so I just used logic instead of any. I used inspection, common sense, guess and check. I informally was like, okay, that's probably a minimum as opposed to a maximum. Because to me, it kind of looks obvious that way out here is going to be a larger distance than right in here. So we had the minimum for x, and in all truth, we could have just gone over here and be like, okay, there's only one -2. But I just want to make sure, so I took that -2, plugged it into our equation for the line to find our y value, and once we had our y value, matched it up with a possible answer. And that's how we found the distance between we minimized the distance between a point and a line. But it could have been any curve. This one was a line. Thank you much. See you for the next question.